I'm excited because this is like the last major piece of C++ syntax you guys don't know yet. It's a thing called exceptions, and you will learn it today, and that will be that. So let's get started. There's a lot to do. It's a different kind of control flow. It's a different way of how the program executes. Exceptions. So let us begin. You will understand this meme by the end of the slides. So, okay. I guess here's my example, my motivating example for this concept called exceptions. All right. So let's say we're dividing something by something else, and we wrap that into a function. So we'd like to make a division function, and you know, right, that when you divide by 0 in your program, if you're using ints, you get a runtime error. Like it stops your program if you divide by 0. So you want to make extra sure that you don't crash the program inside of your division function, right? So here's your function, int divide. It's doing integer division. It takes int a dividend, right? And it divides it by the divisor, math words. And normally you'd be like, all right, return dividend, if I can spell, over the divisor, and call it a day. But that could lead to issues, and let us look into that. So, division.cpp. Very easy example, right? I would like to ask the user to enter a divisor. So int n1 equals 42, n2 is just a variable. We need to fill it. Cout, and I'll divide 42 by that number. Enter a divisor. Get it. And then I'll be like, cout, divide n1 by n2. Print the result. New line. All right, so we'll make our divide function. Int divide, int dividend, int divisor. Return dividend over the divisor. Okay, let's program. What could go wrong? If the user types a number other than 0, this will work just fine. Right? The user enters 2, like, yeah, the answer is 21. 42 divided by 2 is 21. We're fine. If the user enters 0, we get not like positive infinity or anything. We get a runtime error, which is no fun. So we'd like to stop that. We'd like to prevent this kind of error from happening. Okay, and that's the setup. We would like to alert the user, right, that they did a silly thing. You should not have tried to divide by 0. How dare you? Okay, and depending on where you want to handle this error, deal with it, this can get pretty tedious. It's going to eventually, given the stuff that you know how to do right now, it would boil down to a bunch of if statements. Use a bunch of if statements, which is very sad. All right. One way to fix it is all right, whoever calls divide, maybe they messed up, but let's alert them in the division function. If divisor is 0, then we can yell at the user, maybe. But then there's the concept of what do we even give back at that point, right? Well, we can totally yell at the user all day long, but we don't want to crash the program. We don't want to stop the program right now. Divide needs to give back an int. What do we give back when the user is trying to divide by 0 after we print our error, right? That's a difficult question to answer. There is no logical thing to return. You could return infinity, the largest integer, if you wanted to. You could return -1, but then how do you know if it was the error or somebody just divided and it ended up with -1? Right? There's a lot of questions that you have to figure out the answer to, and they're hard questions. Maybe you could start, instead of solving the problem in divide, you could have a bunch of if statements everywhere you call divide. Like, if I'm about to call divide with a divisor of 0, let me change something and do something a bit differently, or yell at the user there. So then you have to worry about like control Fing for all of the times that you call divide, and you have to fix it there, right? Maybe you call divide 100 times in your program. You'd have to change every call, wrap it around an if statement, check to make sure you're not dividing by 0. Do we understand that that is tiring? That could be very tedious. We don't like that. There's a better way. The better way is using exceptions, all right? But let's complete this ugly way first. Here's like, I guess, one way you could solve this problem, and just like I was saying, it's not a good answer. If divisor is 0, let's say, we can yell at the user, bad divisor, new line, and we still have to return something from this function. We could be like return -1. So that's essentially one way to solve the problem. But that might not be good enough. Like if the divisor is 0, yes, we yell at the user and we give back -1. But what if we divided by -42? We also give back -1. Like how can you tell the difference? Right? That's a problem. So that is the setup. That is the issue. Are there any questions about it? We do not yet have the tools to solve it cleanly. You just have to use a bunch of if statements right now. We can fix that with exceptions. So an exception is going to fix this for us. It's going to give us a nice place to handle this error, to alert the user that there was an error and have it be handled in a nice way. All right? An exception is a special thing that C++ has. It's a control flow construct, just like loops, just like conditionals. It's a new thing. It signals that an issue happened. Okay? That's why it's called an exception. So it signals that something exceptional has happened, and you need to go and deal with it. Okay? Somebody needs to go and deal with it. And the metaphor is throwing and catching. I don't know. You're playing catch with the errors. So exceptions, they get thrown when they happen, when they occur. And to handle, that is deal with an exception, you catch it. So, I don't know. That's the metaphor. Here's the ball. It is an exception. It is being thrown. And it's like being thrown somewhere into your program when it happens. Somebody, if you don't want the program to end, you need to catch it, right? In your glove. So somebody needs to catch that exception. Okay, I hope that makes enough sense. Oop. It's my best drawing of a glove. That's the metaphor. An exception, it gets thrown, and your program needs to catch it somewhere. Emphasis on the somewhere, which is really nice. All right, so let me show you an example of handling exceptions. Right? Let me show you this. You've actually already used exceptions. You've seen them happen. They've just crashed your program because you didn't handle them. You didn't catch them. But let me show you an example using vectors. Okay. Vectors, they can throw an exception if you try to access an element that doesn't exist inside of the vector. Let me prove that to you. I think you've seen this before. You just didn't know that it was an error that you could have dealt with. Let's go to the vector library, vector class, .at. Boop. So, if the thing that you're trying to access in your .at is greater than or equal to the vector's size, then it throws an out-of-range exception. Ooh, all right, that's what that means. Let me prove that to you. So vectors, they can throw that out-of-range exception if you try to access an element that does not exist. So let me code that for you. Try catch.cpp. So I need vectors. Vector int v 456 or something. And let's go and see out v at 3. right? It goes 0, 1, 2, 3 is off the edge of this vector. We can't access it. This index does not exist. So if I try and run this program, boop. Wow, terminate called after throwing. Now we know what that means, an instance of standard out of range. So that's the type of the exception that just got thrown. It shows us some information about it. And it stops the program because we did not catch it. We didn't handle it. So C++ just gave up. All right? Couldn't find a handler for our exception, and so it stopped the program. But we could have handled this. We could have solved the problem, and the program didn't need to end. Okay? So, first idea, every exception that gets thrown is just a value. It's a value of a certain type. So an out of range, that's just a type that C++ defined. It's some struct somewhere. It's got some stuff inside of it. You could have thrown an int. The vector library could have thrown an int, a string. It could have thrown a vector back to you. It can throw any type. You can handle it, though. You can catch it. So here was our example in picture form, right? We had 4, 5, 6. We tried to access, those are the valid indices, we tried to access index 3, which did not exist. We got that out of range exception. And the program crashed because we didn't handle it. Here's how you handle it. You use what's called a try-catch block, all right? And inside of the try part, it looks like this, try, then you put some braces, and then you put a catch. And then you can catch different types here. And those also take some braces. Essentially what it looks like. The try part, you put as much code as you want. It's like, please, C++, try and run the code in here. Try to do it. It might throw an exception, though. So it tries to run that piece of code in the try block. And if an exception occurs, and it's of this type, here is where you want to jump to handle that error. All right? That's the idea. So in the try part, you put code that might throw an exception. Maybe it runs to completion. Who knows? Code that might throw an exception. And then in the catch block, you put, it's kind of like a function in a sense that you put the type of thing that you want to catch out of range. And you usually catch it by reference. And then you handle that particular kind of exception. So handle out of range exception. And you can chain a bunch of catch blocks. You can catch some other things. Catch an int down here if you wanted to. ... I'll show you multiple in a second. But yeah, the idea is try to run this code. If it runs fine without throwing exceptions, just, all right, you're done. Otherwise, if somewhere in this code it throws an exception, and it's one of the ones you marked that you knew how to catch, then immediately the code jumps here, handles that particular kind of exception. You have access to it if you need it, and then the whole thing's done. Right? So it just stops your code once the exception occurs. You handle it, and it goes back to the rest of the code down below. All right? So let's catch that out of range exception. Out of range is the type of the exception. By the way, back to the docs. It has a type, you can click on it. Class out of range, it's got some stuff you can do to it. It has a .what method, which is kind of cute. It tells you what went wrong. So, okay, let me show you all this. So instead of what we're doing, let's wrap this in a try-catch. All right? Try C++ to run this code. It might throw an exception. It's definitely going to in this example. Catch, if it throws an exception, here's the kind that I know how to handle. If it threw an out of range exception, I'll take it by reference. Then it's going to jump here, and it'll run this code and handle that error. So C++ jumps here if an out of range exception occurs in the try block, right? And so you just need to do whatever you need to do to handle that exception, right? It could be like cout, I don't know, whatever you think to do to deal with the exception, handle the exception. Maybe that involves asking the user for another index until they get it right and it's a valid one. Something like that might work. It's whatever you want to do. It's up to you. Whatever you need to do to handle that exception and get back on track in your program. Every out of range exception has a method. It's an object. It has a method inside of it called what, which is a cute name. e.what you can call it, and that returns back a string that indicates what went wrong. Isn't that funny? So I'll print that out as well. So now, when the exception occurs, we don't get a scary error at the end. The exception happens, we jump here, it's an out of range, we get it, it's called E, and we just run our code to handle the exception. So we print we print whatever the what gives back. It was apparently, this was the string that was inside of the what. All right. And that's actually what it's actually calling that for you. If you don't catch it, it's going to print the error for you, and then it crashes your program. All right. But we handled it. The program ended gracefully, perfectly. Everything was fine. We dealt with the error. Are there any questions about that? It's a try-catch block. Try to do code that might throw the exception, and catch. That's where you handle different kinds of exceptions that may have occurred inside of that try block. All right. So that's just one side of the coin. The vector was throwing this exception. Let me teach you how to throw exceptions too. How do I want to start this? Yes, that's what we're going to have to do. All right. Let me show you how to throw your own exceptions now. So you can throw any type, first of all. You just say, the keyword is throw. You can say throw 42, and that throws an exception to somebody who needs to catch it in a catch block somewhere. You could say throw 3.14. You can throw any type at all. But usually you want to throw a type that has some information inside of it that indicates the error. So runtime error is a nice exception to throw. Out of range is a nice exception that you could throw yourself if you wanted to. If you wanted to build up it. But runtime error is a nice exception. It's defined in this header, standard except. So let's go look there. I assume it's in other. Standard except just has a bunch of exception types. Logic error, invalid argument error, out of range. And then here's runtime error. That's just a standard one that you can throw if you want to. To create a runtime error, its constructor just takes a string, and that's what it's going to store inside of this what thing. So it also is able to be called with the what member function, which is fun. All right, so a runtime error is just a class that indicates an issue. It takes a string in its parameter, or in its constructor. That's one thing that you can throw. All right, so runtime error's constructor takes a string and it returns that string when you call what on it. But you can throw any type at all, 42, 3.14. So let's write a bunch of throwing functions. Let's write a throw string function, a throw int function, a throw runtime error function, and we'll catch them. All right, we'll catch them maybe randomly. I don't know. We'll figure this out. So let's call it throw.cpp. I would like to eventually throw a runtime error, so let's include standard except that holds runtime error. And then we also need to pass along strings, so we'll be working with strings. So yeah, let's make functions that throw stuff. Throw string, throw int, throw runtime error. Why not? So I don't know. It's gonna have any return type because it's not gonna ever get to return anything. Throw string s equals blah. Throw s. So you call this function and it immediately indicates that an error occurred. It throws the exception. Let's do throw int. Throw 42. Throw runtime error. So you can build up a runtime error object like this. Runtime error. That's the name of the type. I don't know, call it RE. That can be the string that lives inside of it. And you'll throw that. Throw RE. Oops. So, yeah. All of these functions, if they get called, they indicate that an error occurred, and they throw that particular type to you. Okay? So, gosh, how do I want to deal with this? This is going to get a bit fancy. Let's catch them in main first of all. Let me show you how to catch different kinds of errors. So, main. Where do I want to deal with this? We're going to need to try catch in main first of all. Try catch. We're going to do some stuff. But I think I'd like to put the exception throwing in another function, just to show you like that it could be a weird, like it could be very far away where the exception occurs. Like, let's make a function called do stuff. Void do stuff. And let's have that one, I don't know, let's have that one throw a string, throw a runtime error, and throw an int. Something like that. And then in our catch block down here, we call do stuff. Do stuff might throw an exception. It's going to call throw a string, which will throw a string exception, right? Up here. There's a lot going on there. Hopefully you're following it. Please yell at me if you're not. And then so we try to do this, and we catch any exception that may occur inside of a catch block. So this could definitely have thrown a string. It will. So let's catch that. And this alerts to C++. It's like, hey, I know how to handle a string exception. You could be like, I don't know, cout, caught, string in main. And here was the string s. We can take that. It's like a parameter, essentially, in the catch block. We could also have, and customarily you catch things by reference. So I'll keep doing that. It could also have thrown an int, so you just chain a bunch of catch blocks. Catch an int. By reference, why not? Int I. This is saying, I know how to catch an int. I know how to handle an int exception to C++. Please go here if you see an int be thrown. I know how to handle an int exception. Caught an int in main. A string. An int. And that's how you handle it. It's like, all right, we can do fancier things, of course. Catch. Another thing that could have been thrown was a runtime error. Runtime error by reference E. This is alerting to C++. I know how to handle a runtime error exception. If that gets thrown anywhere in the try block, in any code that I'm calling, in some roundabout way maybe, it's all going to work out. Caught a runtime error in main. And you can't like print out the runtime error. You can print out e.what though. I'll give back a string. Okay, so that's the program. Let's compile and run it. Throw.cpp -o throw. So this does not crash, but it throws a string and we catch it. So let me walk you through how this is running. Main tries to do stuff, right? And it hooks up all these handlers right here. If a string gets thrown, it'll go here. If an int gets thrown, it'll go here. If a runtime error gets thrown, it'll go here. And so we call do stuff, and the first thing do stuff does is throw a string. And so that just stops everything, right? The second an exception gets thrown, all of your code stops and it finds a catch block that knows how to handle that thing, right? So it does not go on to throw a runtime error or an int. Like, that's it. It jumps here, and then the whole try catch is done. Does that make sense? Because essentially, if an exception occurs, you need to stop everything, handle that, and try again if you want to, right? But it definitely doesn't jump back to where it was in the try block. That might be a problem. You might have to reset everything, all right? So you have to do that as a programmer instead. So yeah, if we throw the int first, it'll catch the int, and that's going to be the whole program. Caught an int in main, so it goes right here. Do stuff, throws the error because it throws the int. It goes to this catch block. We handle the error. Okay, and the program continues. So it's stuff down here. See out. Rest of the program. Dot, dot, dot. New line. And then finally, I could throw a runtime error first. Why not? Boop. Got a runtime error in main. Because do stuff throws that runtime error. It stops everything. It jumps straight to the catch block for a runtime error and it handles it. Right? If we were to throw a type that does not have a handler, like throw 3.14, that would still crash the program. We don't know how to deal with a double, throwing an instance of double. I didn't give a handler for that, so that still crashes the program. You got to give a handler for every kind of exception that might occur. All right. So just to make it fun, let's do it randomly. Include cstudlib. Include ctime. Remember all this? srand time 0. And now let's randomly throw one of these things. If rand mod 2 is equal to 0, it's like flipping a coin. If it's equal to 0, then throw a runtime error. I don't know. Really, I guess to make it evenly balanced, I should do it this way. Int choice equals rand mod 3. And now we can branch based on which it was. If choice is 0, throw a runtime error. Else if choice is 1, throw an int. Otherwise, throw a string. So this will perfectly balanced throw a different kind of exception each time. And so we can watch our program catch every kind. It knows how. Caught a string, caught an int, caught a string, another string, caught an int, caught a runtime error, yay. Randomly. Any questions about the program so far? Does that make sense? The power of exceptions, first of all, is noticing that like do stuff doesn't throw the exception. It's one of these functions, like throw a runtime error. We jump here. We're in a bunch of code, and that's where the exception occurs. It unwinds everything and goes back to main. That's a very nice thing. Okay, it jumps to the nearest handler. That's really cool. That is very helpful. But do you remember? Yeah, the try block, it stops executing everything when the first exception gets thrown, right? If you have a very long try block, you might have to like reset everything to go back. You might have to do a lot of recovery, so it's best to like split it up. And if there are a lot of different kinds of exceptions that get thrown, you might have a bunch of handlers that you need to add in your catch blocks. Okay. So I think the next thing that I want to show you is that you can have multiple try catches. There's an idea of a stack of exception handlers, just like there's a stack of function calls. And C++ builds up that stack. It goes to the closest handler. All right, so let me show you that when an exception occurs. So let's say that inside of do stuff, we add a try block. These are the pieces of code that might throw an exception. Let's put those in a try block, right? So I have two try blocks, one in main, one in do stuff. And let's say that do stuff knows how to handle a string. And let's handle it up there. So it's saying I know how to handle a string exception myself in do stuff. Caught a string in do stuff this time. Okay? So watch what's going to happen. Sorry, it's hard to show you all this at once, but here's do stuff. Here's main. There. Hopefully that's helpful. So runtime error, if we throw a runtime error, it's still gonna, like, we don't know how to catch that here. It'll go to this handler. That's the nearest handler for a runtime error. Same with an int. If we throw an int, it'll go to this one, this catch block, because that's how it handles the int. That's the closest handler for an int. But if it throws a string now, it goes to the nearest. Throw string is going to throw a string. It's going to go to the nearest handler for strings. All right, the nearest handler for strings is not in main anymore. It's now in doStuff. So it's going to catch it there, and it's going to handle it there. Does that make sense to us? That's important. So like, the closer you are to the problem, it's like, all right, it gives this one preference because it's like, all right, you must know a bit more about the state of the program. You're closer to where the error occurred. So I'm going to prioritize this handler over any other string kind of handler. Okay? That's the idea. And so we could also catch a different kind of thing there. Maybe we can catch a runtime error in doStuff as well. And so this is saying I know how to handle a runtime error. So how to runtime error in doStuff. And I can say .what again. Okay. So back down to main. Here's the try catch block in doStuff. All right. So there's a lot going on there. Are we ready? So now I've put a runtime error handler inside of doStuff, so it's going to skip over this one. All right. I think I just showed it, but so the only thing that's going to be caught in main now is ints. Oh, is that the sound of rain? Cool. It's been a while. So we caught an int in main now. That's the only kind of thing that's going to get caught in main. Here's main down here, by the way. That's the closest handler for an int. The other two are up here now. So when we throw a string, we're going to catch it and doStuff. We're going to go here. When we throw a runtime error, we're now going to also catch it and doStuff. That's the closest handler for a runtime error. And so you can build up a bunch of different try-catch blocks and potentially handle things different ways. Any questions about that? You have options. And then I also want to say in main, just briefly, it's the very first exception. It's always the first one, right? The very first exception gets handled in a try-catch block. And that's the end of the entire try-catch block. Okay? That's the idea. Okay, so with this in mind, let me try and draw what's happening, what C++ is doing, how it knows to go to these exception handlers rather than this one and this one. And like, also remember that in's here too. So it knows to go to the closest one. C++ is keeping track of which try-catch blocks you're currently inside, just like it's keeping track of which functions you're currently inside. And that's how it knows where to go. So like, just like the call stack, you had main, who calls doStuff, and let's pretend it threw the string this time, so it calls throw string randomly. So you're inside of all these functions, and this is where the error gets thrown. This is where the string gets thrown, right? What also is going on inside of C++ is it thinks about where we are inside of try-catch blocks. So in main, we were in here, right? We were in this try-catch block when we called doStuff. So this is the exception handler stack. I'll draw it in green. Exception. Exception handler stack. So when we jump into this try-catch block, it's alerting C++ as we run doStuff, all this code in here, whatever it is, we know how to catch a string, an int, and a runtime error. So it's saving like, all right, main knows how to catch a string, like main knows how to catch a string, main knows how to catch an int, and main knows how to catch a runtime error. I'll jump here if I see an issue right now, if any of those get thrown. And then main knows how to catch a thrown runtime error. All right, and then we go to doStuff, we call doStuff, and so now we're here, we're in this code, and we also start running this try-catch block. And that try-catch block sets up these handlers. It's like, all right, as you're running this code, C++, I know how to catch a string and I know how to catch a runtime error. So it saves that. It saves that information. It's like, all right, inside of do stuff, I know how to catch a string and I know how to catch a runtime error. Okay? And so the second the string gets thrown, it goes to this stack. Once an exception gets thrown, it goes to its little stack and it starts popping stuff off until it finds a string handler. All right? And this is the topmost one. It will never handle the string from main as it's in the inner try-catch block of do stuff because this is the string handler that it has set up now. So once the string gets thrown, it jumps straight to here and it forgets about main's ability to handle strings. Okay. So this is the closest matching handler. Closest matching. That's the idea. So C++ starts looking at its handler stack the second that an exception gets thrown, and it finds the first handler that matches that particular type of thing that got thrown, jumps to that code, and calls it a day. Okay? Any questions about any of that? That was definitely a more complicated example, I would say. Bunch of tries and catches and throwing. So now you know how to do anything with exceptions. You can handle them and you can also throw them yourself. Okay? So with that, we are ready. We can go full circle now. Here is the idea. Let's fix that division example finally. Let's do it right. Let's have it throw a runtime error when an issue occurs, right? And that's going to solve all those problems that I was talking about. Let's call it this. I'll steal all this code. Let's call it division fixed. Paste this in. I'll include standard except so I can have a runtime error now. So now if the divisor is 0, don't just do weird stuff. Throw a runtime error. And I'll just build it up in the constructor as I go. Division by 0. All right? And now notice, I don't have to worry about returning an int. It's just going to jump to the handler now. I don't have to return some weird special value that I can never use again. I can just throw an issue, throw this error, and somebody will hook into this and mark that they know how to handle a runtime error. And that's how we'll deal with this problem, right? That will help us. So here's the idea. Here's my silly way to handle this. Let's do it with a loop. So here is the code that might go wrong. I'll do this in a very weird way. I'll put it in an infinite loop. And then I'll put a break right here. So if everything works out, which it might not, this only executes once, right? It stops the loop, the program's over. But if a problem occurs, this is cute, probably not the best solution, but it's an interesting one, I would say. I'll put that in a try inside of the loop. Boop. And, all right, if we get an issue, right, if the user enters 0 as the divisor, a runtime error is going to get thrown. So we'll catch it by reference. And here's how we can handle the error. Here's a non-trivial way of handling this error. We could just ask the user to do it again, right? Handle the error. Handle the error. Oops, I need 2 slashes. By asking for just another number. So cout can't divide by 0. Try again. New line. So this is a nice use of exceptions. Now we can solve the problem in this way. So if I enter divisor 2, it'll just run normally. I type in 2, it divides by 2, prints it, and breaks out of the loop. It only executes once, it's fine. But if I do this, enter divisor 0, oh shoot, sorry. I was supposed to call division fixed. Again, it still works. Enter divisor 2, it stops the program. Everything works out. But if I enter divisor 0, or up here, it throws the error, throws a runtime error, division by 0. We don't actually look at the string in this example. It's okay. We jump immediately to the catch block, right? We don't stop the loop. So cout can't divide by 0, try again. This whole thing's done. The loop isn't over yet because we didn't break. We would only have braked if we got to the end of the try block, which we did not. So now we're back to enter a new divisor. We handle the error by making the loop start again. Enter divisor 0, and I can do this all day long. If I keep messing up until I type a normal divisor, it's not going to stop the loop. And so that's a nice way of handling this error. I didn't have to do weird if statements other than the one that was really necessary inside of divide. And I can pass off this error to whoever knows how to handle it. I don't have to immediately handle it here. I could let other people, depending on what they need to do to fix the problem, I can let them have their own try-catch block. All right? And they can handle it, and the user can handle this issue in the way that works best for them. And here's maybe a way that works good, well for us right now. Okay? So that is the idea of exceptions that makes our lives quite a bit easier, I would say. But it's a new kind of control flow. Like everything stops, like the world stops. All this code stops and it jumps to the nearest catch block, which is a new kind of thing for us. Okay. Any questions about that? All right, for our last trick, I have a question for you guys to try as a group. Please help each other. Here is my question for you. So I'd like you to add an exceptional case to our recursive factorial function. Remember that one? So let me give you that code and I'll show you what was going wrong before, right? So I'll give it to you on Discord, or I'll just paste it to the slide as well. So I'll open up Discord if you want to go there. Assuming my computer can handle it. But let me copy in. I have no clue what lecture it was, though. Was it not that one? About 21. Factorial.cpp. Let's copy that here. So here was factorial.cpp. Do you remember the issue with factorial? If you ask for the factorial of, let's get rid of the iterative version. If you ask for the factorial of any number smaller than 1, like the factorial of -1 or something, it will just never stop, right? It'll be a stack overflow if the user gave us a number like that, which is no fun. So we should never let the user do this, is the idea. Oh, there you go, Discord, good job. Segmentation fault because we ran out of stack memory. So yeah, we don't want that to ever happen. That's an invalid way of calling fact, right? So what I'd like you to do is, my computer's very slow right now because it's got Zoom open. It's trying to do too many things. It's very small. Here's fact. I'll give you the code on Discord as well. Here's the code for fact. Boop. It's thinking about it. And then here's also some code with exceptions that we were doing today. I'll just give you the whole division program, why not? So go look at this on Discord if you'd like. And I'm definitely going to close that now so that my computer can run fast again. with that in mind, I'd like you to change factorial. Change fact to have exceptions. Add that exceptional case. If the user gives you a number that's 0 or less, then add an exception. Don't let factorial of -1 segfault. You should be throwing maybe a runtime error or something. Throw like a runtime error so that the user doesn't run into an issue like they have to handle that problem. It's a lot cleaner and a lot better of an issue, right? A much better thing to solve, writing a handler than like tracking down a segfault. Okay? That's the idea. All right? So yeah, this was the issue. We don't want to get here if the number is -1 because you'll just keep going getting smaller. You'll never get to 1 if you're already negative, right? So add an exceptional case to your factorial function. Add an exception getting thrown. And see if you can also handle it in the main function, right? Or the main function that handles it. Again, the reason fact was the problem is because fact of -1 called fact of -2, which called fact of -3, until the end of time. Da, da, da. All right? And the nice thing about exceptions is when you think about them, it forces you to like figure out how your program could possibly go wrong, and that makes you a better programmer too. Okay? So yeah, give this a try. Take a few minutes to add exceptions to this factorial program. Look on Discord if you wanted the code. You can copy and paste there if you'd like. But help each other get that working. And then I'll do it for you, or do it with you in like, I don't know, 3 minutes. Take about 1 more minute. Some good discussion. All right, that is my timer. Were there any questions that came up as we were trying this? Because I'm going to do it one way. Maybe that's a different way than you were thinking about. I don't want to answer any questions that you have. Well, here's my idea. Like, all right, factorial, we do not want to have this seg fault. So if n is less than 1, right, 0 or smaller, then it's in the exceptional case. Let's throw a runtime error. Or you can throw it in, throw 42, whatever you want to do. Just make it not seg fault and don't try and return an int, right? Don't return some weird value that indicates an error happened. That's a bad thing to do. Exceptions are always the better option. Throw a runtime error, and I don't know, can't calculate the factorial of numbers smaller than 1. Sad face. Technically, that's a lie. Factorial of 0 is defined to be 1 as well. But let's just sweep that under the rug. And so now, instead of doing this, we can try catch it. Try catch a runtime error. Oops. And we can be like, I don't know, see out e.what. That can be the way of handling it. And then your program gets to continue instead of crashing, instead of seg faulting. Yay, can't calculate the factorial of a number smaller than 1. And it'll work for any other number, like, I don't know, calculate the factorial of 5. It's still okay. It's just when it does -1, that's when the error occurs, right? All right. So yeah, that's the way that I would have solved it. Throw a runtime error up there, and then add a try catch. Oops. I'm not in Vim. There we go. Throw a runtime error, and then add a try catch down in main. Any questions about that? Is that the way that we were thinking? Oh, that's the runtime error. It's an object, and you could put inside of it a string. Any string you want to like describe the error that happened. And if you call .what on a runtime error object, like I'm doing here, e is a runtime error object, it just gives you back that string that you put inside of it. So that's why it's printing all this, because that's exactly the string that I put inside of it. Does that make sense? Yeah. So that's the only thing that a runtime error can do. It's just it's a nicely named type, but all that lives inside of it is a string. So if you want to give back more information about your error, you'll probably need to make your own maybe struct or class that could hold all the information that you need to hold when you want to throw that issue. Okay. Good question. Any other questions? All right. I believe that's all that I wanted to talk about today. Let's take a look. Confirm that. Yeah, lab next time. But that is everything that I wanted to talk about today.